conference is being recorded.
Okay. Yeah. So your voice is also recorded along with mine. Right? Yeah. Okay. So I'm going to keep this lecture. The previous lecture is must be on Moodle. Maybe Himanshu will keep it maybe today. Right? So thereafter you can see the previous lecture also and today's lecture also. Yeah. So very quickly, can you tell me somebody how much is let's say 54 dB in volt per volt? 54 dB in volt per volt. Use some engineering.
10 to the 2%.
Huh?
10 to the 2%.
Wrong, wrong, wrong. So we know what is 60 dB, right?
500, sir.
500 volt per volt, right? Okay. How much is 48 dB? 250 volt per volt. Every time when we are moving backside, it's divided by 2. Another side like 56. If it is 66 dB, 2000 volt per volt, right? 6 dB is equal to double. 60 is already known to us, 40 is known to us, 20, all these are known to us because it's 10 raised to some x, right? Let's look at this. I'm telling this because thereafter I'm going to talk about only decibels, not volt per volt, right? There is just one small mistake I made when I was talking about dBV. Anything which is in ratio cannot be dBV. Sorry, okay, there was one mistake from my side. So if uh, if there is some voltage like 10 volt, I want to convert this 10 volt to decibel, then it's 20 log 10 base and 10 is equal to 20 dBV. Okay, so that was just a correction. If there is a ratio, then it's decibel, it cannot be dBV. Okay. Just for information, like, have you ever seen semi-log paper? You heard about semi-log paper? Log paper. What is log paper? Not log table. You are saying yes. That's a graph.
No
Yes.
graph paper.
Yes, yes. Log. Log graph paper. Have you seen
We
it?
do that body plot on tape.
But you are saying that you never studied Bode plot.
I know it.
Yeah, but you are claiming that you don't know Bode plot. That's why I'm teaching everything from zero. Huh?
I don't know. I study.
Where have you studied Bode plot?
Because of the project, that's why I studied.
Okay. So how many are like him who knows Bode plot? Okay. Second, he can help me as a TA maybe on Monday. Because we need some people will be sitting like among you people, so that on Monday we have a small tutorial on Bode plot, how to make that using Samilog papers. So I was inquiring in our stationery, but they don't have Samilog paper. By the way, what do you think? Why do we need log paper or Samilog paper? Of course, plotting. If I'm asking you why do you need graph paper, of course, plotting, right? It's also a graph. But why do you need log? Okay, before that, why do you need dB? dB is also kind of log scale, right? So why do you need decibel? Values are very large, right? So let's assume that if I want to plot something from uh, millihertz to terahertz, is it possible on your graph, normal graph, linear graph, right? So on semi-log paper, you can plot them. I'll teach you how to read that log paper. If you, yes, I'll teach you small part right now. So every line is 10 times actually higher. So if this is 1, then this is 10, this is 100, this is 1000, this is 10 raised to 4, 10 raised to 5, because this is with log base 10. That's why this is happening. And we are going to call this one as decade. And if it is Generally log scale looks like this one: 20, 30, 40, 50, 60, 70, 80, 90, and 100, something like this. So if it is double 10 to 20, then it's known as octave. These are the words you should remember. You can keep it somewhere, right? We are going to use these words.
Line between the two.
Not line between, something multiply by 2 in general we are going to call octave. Multiply by 10 we are going to call decade. Just to find out some slope, because Bode plot is dealing with slope. Till now we have not learned it, but slope is measured in decibel per decade or decibel per octave. This is the standard practice people are following. So we are going to use this one. All the electronics engineers, they are following dB per decade. Means analog circuit designer, digital, all these. But if somebody is RF circuit designer, then he is using this. Or control engineer, generally they use dB per octave, right? But this is popular for us. That's why I'm teaching this. In your control theory course also, you are going to learn only dB per decade. But I'm telling you, those who are the designer, they are going to use dB per octave also. Okay. So this was one thing which was left in decade and octave. So there is no doubt about this table, right? What is decibel, and how to convert it to volt per volt, or maybe in volt, or maybe current, right? It might be ratio of current, but in the ratio of power it's 10 log. Just remember this, right? Now let's still, this is not real Bode plot which we are learning today. This is just magnitude plot, and then we will shift it to Bode plot on Tuesday. And yeah, tomorrow is laboratory, right? 10 to 12. So have you seen such transfer function in the form of any circuit? Do you know any circuit which looks like this one? Yeah, you've seen it, right? RC. All RC circuit are actually 1 by s plus 1 or some different number, right? Or this number is depending the time constant of RC, right? Why we are doing this? You must have seen this circuit many times in many courses. RC circuit, this is a fundamental. Believe me, if you'll go to any job interview also, if it is electrical engineering or electronics, they are going to ask you RC. Why it is so special about RC? What do you think? Why just RC? L is also there, so we are going to learn that also, but let's understand why RC. Why RC? Why should we learn? Sorry? Most systems are, it's not true also every time. But most of the systems are, when it's modeled, let's assume that there is a wire. This wire, so I'm teaching a little bit of what you studied in IC 161. So this is an oscilloscope which has two channels, channel 1 and channel 2. Let's assume that we are in 18th century when people were doing this experiment first time, and they were connecting, these are just wires, these are wires. Okay, so what theory of electronics says, if there is a path, so if there is a path through which some current is flowing, that path will have some resistance for sure, right? Path will have some resistance. So if I want to draw this one in my notebook, I am going to tell that this is just not a wire, but it's a wire with some resistance. If this resistance is like, if I'm doing this wire business, and this resistance might be varying. Like if Amol is using one wire, he will have some resistance, maybe 1 kilo, 10 kilo. If somebody like Rishabh is there, okay, today he is absent, so maybe he will have different resistance. right? And all these things are depending on one equation, right? You must have studied in your physics, right? Through which this will be always some different value, but we don't like it, so we need to standardize it. That's standardized by three different people, BNC. They told that let's keep this path resistance as 50 ohm. That's the standard, and that's the agreement between all of us, or all the scientists. They are going to make it 50 ohm, or whichever company we are going to buy it, it has to be 50 ohm for audio, right? So it might be this wire will not be like this, it might be covered with something. So assume that there is some, it's covered, just covered, like green, red, yellow wires you must have seen in our electronics laboratory, right? But here the problem starts. So if there is a path, there is a resistance. This was one thing. There is one more theory I am telling you. This theory says that, hmm? Yes, yes, I am talking about that. Yeah, so if this if these signals are frequency signals, they are not DC, right? Or either of them is frequency signal, then let's assume that I am feeding here something like this, and here I am feeding some DC 1 volt. If both side DC, then this rule doesn't work, by the way. The rule which I am going to write, this rule says that if there are signal which are frequency signals, and there are two dissimilar plates, by the way, writing is good or bad? Some last time in my course somebody told that my handwriting is bad, so in flow I am writing this way. If you want, I can write it better way also. Okay, you can read it. Okay, so if there are two dissimilar plates, when I am saying two dissimilar plates, means there are two wires, two plates are there, which has different voltages. Here if it is DC equal to 1 volt, or if I am saying 1 volt 1 kilohertz, 1 volt 1 kilohertz, then this rule doesn't hold, right? This rule works when both are different, 2 volt 1 kilo, or some different voltages with different frequencies. Then we are going to call them as two dissimilar plates. If there are two dissimilar plates, then, so if the situation like this, then these plates are going to be coupled by some capacitors. These are not visible by your eyes, either resistance or capacitance. They were not visible by your eyes, but when you are looking at in reality, they were contributing like RC. All these are R and C are known as parasitics, which you have not made it, but they are parasitics, right? Or killing your performance, right? So that's why this is the most